Hello, Breakthrough Side here. I'm speaking on behalf of the Forward program, which is a Kenyan mentorship program that's designed to help teach Kenyan orphans at a local orphanage center certain bike-related topics, engineering topics, physics, and math-related topics. So today we're going to be talking about projectile motion. Now, really, what is it and why do we need projectile motion? This is a physics concept we're going to be going over. Projectile motion is the motion of an object projected into the air and moves under the influence of gravity. Now, why is it important? It helps us understand the motion of an object when launched into the air. So essentially, the object's movement is essentially dependent on gravity. You can see at a certain degree, at a certain x and y component, when you kick a ball, the gravity will basically determine how the ball will essentially move at certain points, at certain vertexes, and how it would essentially move throughout this parabola. Certain formulas that we're going to go over as well is the y component. This is essentially, the first one is the projectile formula. This is essentially y equals negative 4.9 t squared plus the initial velocity, times that by sine theta, times that by time, plus that by the initial height. The subscript I, subscript O for 0 for certain components, so as it represents as the initial part of that component. This is the initial velocity, this is the initial height. Theta represents, the degree of the angle, and t represents time. This is the horizontal component, the xt component. This is essentially equal to the v initial times that by cosine theta times that by time. You can see here there's some a little bit of errors here, but that's completely fine. This is essentially the y-axis. Certain components go in, so the x component goes with the x-axis, y components go with the y-axis. This is essentially the vertical velocity, or the vy component, known as the range. The vx, I think that's, no, this is the vy, this is the vertical velocity. The range is essentially over here. The vx component is essentially the horizontal velocity that goes over here. Maximum height, that's essentially the distance between the x-axis to the vertex point. And you can see at a certain degree, that's also shown. You can see here as well that if you change certain parameters of the initial components, you can see that the behavior of the graph will change as time goes on. And you can see here that the x and y component, the vx and the vy components are also established in the horizontal component and the projectile formula component as well. Sine represents the y-axis, cosine represents the x-axis. This is how a typical quadratic quadratic equation would look like. You can change the a to invert, c would change, the vertex, and b would just change, the behavior of the graph. And you can solve for quadratic formula and discriminants as well when you're plugging in a, b, and c. If you want to solve for any quadratic equations and projectile equations as projectile formulas, you can plug it into Wolfram. And in Wolfram, they actually give you the answer right off the bat. They give you, certain imaginary numbers and also actual x real values. They do it for you, which is very, very awesome. So yeah, I hope this is a very good, fun video for you guys. And yeah, thank you guys. Syed, signing off. Take care, guys. Wishing all the best for you, Breakthrough.